Alright, so we're going to start with this reaction from the last video. So what do we have? The first thing, of course, is lead 2 hydroxide, right? There's the lead, it's 2, and that's the polyatomic ion hydroxide, goes to HCl, so that's hydrogen chloride. That's actually known as an acid. Anytime you have hydrogen and one of these one of the halogens that forms an acid. So we'll talk more about that later, or actually we won't go more into that. And so that's the reaction that goes to water plus lead 2 chloride. Okay, so there's the lead 2 chloride. Notice the hydroxide does not survive on both sides, right? There's the hydroxide. So we don't balance the hydroxide, it's going to break up. All right, so we start, of course, to balance this, we're going to start with the most complicated molecule, or compound, I guess, the lead 2 hydroxide. So the lead looks good, right? There's one lead and there's one lead on the other side. We'll hold off on the oxygen and the hydrogen because what we're going to do is look at the chlorine. So the chlorine, there's one of them on this side, there's two of them on this side, so we're going to need a 2 right there as our coefficient. So now let's see what that does for us. Okay, so on so the chlorine is balanced, of course. The lead is still balanced. So let's now look at the hydrogen and the oxygen. Okay, so on the left-hand side we have there's 2 plus another 2, so there's 4 hydrogens on the left-hand side. There's only 2 on the right-hand side, so if we put a coefficient of 2 right here, that balances the hydrogen. But notice that also balances the oxygen, because that gives us 2 oxygens on the right-hand side and now 2 oxygens on the left-hand side. And so that's a balanced equation. A little more complicated, agreed, but still balanced. All right, so the next one, here's what we have. Let me draw it out. So we have aluminum bromide, right? Aluminum and bromine, right? So that's called aluminum bromide, plus, what is this? Potassium sulfate. So K, and of course there's 2 of these, and then there's the sulfate, SO4. So there's one of our polyatomic ions, and that goes to potassium bromide, plus aluminum sulfate. So Al2, and then that's a 2, and then the SO4, and because there's aluminum's charged plus 3, so there's 3 of these. All right, we're not interested in that. So notice this time we have a polyatomic ion, the sulfate in particular, on both sides of the equation. So let's start with this. Remember, this is a 2 right here. It doesn't really look like a 2. Anyhow, since there's 3 sulfates on this side, I'm going to need 3 sulfates on that side. Okay, so that's the only way that you can balance that, is to start, with this very complex compound. So now, how many potassiums do I have? 3 times 2 on the left-hand side, and so there's 6, so I need to put a 6 right here. All right. Well, I have 3 bromines on the right-hand side. I'm sorry, on the left-hand side, but there's 6 bromines on the other side. So if I simply put a 2 right here, that gives me 6 bromines on both sides. And then notice I have 2 aluminums on the left-hand side, and I already have 2 aluminums on the right-hand side. So so that balances it. Okay, so very nice. Let's work on the next one. So we have CH4, better known as methane, plus oxygen, the oxygen gas, right? In its gaseous form, there's always two atoms. So goes to carbon dioxide plus water plus H2O. All right, so let's just take a quick, whoops, that O didn't come out. So let's take a quick look at this. So the carbons are already balanced, so let's start working on the hydrogen. So there's, on the left-hand side, there's 4 hydrogen. I need to put a 2 right here. So that gives me, well, that's a temporary 2. We might have to change that. Let's see, so that gives me 4 oxygens. Oh no, that's fine. So there's 4 oxygens on the right-hand side, right? There's 2 here, there's 2 here, and so there's 2 on the left-hand side. So if I just put a 2 right here, that is balanced. Let me make sure here. 4 hydrogens, sorry, 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens. Very nice. All right, and let's see. What's the next one? Oh my goodness, that's a little more complicated. So let's see. So this is C3H8 plus oxygen goes to carbon dioxide and water. Once again, there's lots of these reactions in nature. All right, so did I get it right? C3H8, yes. All right, so let's start with the carbon. That's pretty easy. We're going to have to put a 3 right here because there's nowhere else to balance the carbon. So the next thing is the hydrogen. So there's 8 of them on the left-hand side. So I've got to put a 4 here. So now there's 8. So the hydrogen's balanced. All right, so let's see. On the right-hand side, I've got 3 times 2. So this is for the oxygen. 3 times 2 plus 4. All right, so I've got 10 oxygens on this side, and the only way the simplest way to get 10 is to 10 oxygens on the left-hand side is to put a 5 right there. So 5 times 2 is, of course, 10. All right, and let me just show you real quick where I'm getting these from. Oops, not that. Sorry. These are all coming from the PowerPoint. Not PowerPoint, sorry. Where I say balancing chemical equations, there's just let me find it. Let's see. I think it's this. So see, I just copied these this Word document, and if you keep going down, it gives you all the answers. So they're all there, just to let you know. And you can do these. I'll probably do a few more with you, but they show you the answers. So like number 16, for example, was already balanced. But before you look at the answers, make sure you practice this stuff. It really, I don't think there's any other way to learn this without just simply practicing it. Here, let me see. All right, so in the next homework set, in homework 11, as you can see, there's some word problems, and I want to go through some of these, or probably all of them, with you. Let's make that disappear. And sorry, I should have already done this. There we go. All right, so I'm just going to paste that right there. Oops, you can't really see that, can you? Here, let me. All right, so hopefully you can see that a little better now. So with these homework problems, with the word problems, I just want to make sure that we go over this. So we have zinc, right? So there's zinc, plus lead 2 nitrate. Okay, so lead 2 nitrate is going. Remember, nitrate If you want to do this off to the side, that's fine. So lead 2 would be Pb2 plus, and nitrate is of course NO3, and it's charge -1. So lead to nitrate, you do the crossover technique. I'll do it up here. It would be Pb, and then in parentheses, it would be the nitrate, NO3, and of course there's 2 of them. All right, so that's supposed to be a 2, sorry. So PbNO2, NO3, there's 2 of those. React, so when it says react, that's the reaction. In other words, it's going to the reactants to form zinc nitrate. Okay, so zinc, if you remember, is charged +2, right? And remember, it's not zinc 2. Zinc is one of those special ones. It's always +2, and so zinc nitrate would be for the same reason as the lead 2 nitrate. So the zinc nitrate would be Zn, and that would be NO3, and of course, there's 3. There's a 3. That's supposed to be a 3. There's 2 of those. That's a messed up looking 3. And lead. And so when it says zinc and lead, those are just the metals by themselves. Okay, so it's the metal. All right, so there's the. What's nice about this? Okay, what I like about this, and I think you'll understand, is that that doesn't look like an O. Sorry. Is that this brings some of Chapter 9, that is naming the compounds, into Chapter 10 stuff. So that's what's kind of nice about that. Here, let's do another. So aluminum bromide. So just remember aluminum. Oh, come on. Aluminum is always +3, and bromine is one of the halogens, so it's -1, so it's AlBr3. So that's aluminum bromide, plus chlorine gas. So this is something you might not be familiar with. So for chlorine to be in gaseous form, it's Cl2. Okay, so I'll always give you that, just like in the last one with the acids. I wouldn't expect you to know what the acids are. All right, and then it goes to aluminum chloride, of course. So aluminum is +3, chlorine is -1. So there's 1 aluminum and 3 chlorines, and it goes plus bromine gas, right? Bromine gas is just there's Br2. Okay, so that's kind of nice. So I'm just setting up. You still have to balance it in the homework. Okay, so let's look at the next one. All right, so here's the next one from the problem. So we have phosphate, which is PO4, and it's charged -3. So it's just to remind me how this works. Okay, so sodium, of course, is +1. So Na+1. All right, so here's the reaction. So sodium phosphate is going to be Na, and it's a subscript 3, right, from the charge of the phosphate, and then PO4. There's the phosphate. And calcium chloride. Okay, so calcium, just to remind ourselves, calcium is +2, and chlorine is -1. Okay, so that's going to be plus. Do you see how this is very much related to Chapter 9? I hope you're seeing that. So that's going to be Ca, and then it'll be Cl2. So there's the calcium chloride. React. Okay, so that's telling us it's going to reactions to this reaction. A calcium phosphate. So calcium is +2, phosphate's -3, so here we go. Remember, we're using the crossover technique, so the calcium would be Ca 3, right, from the charge of the phosphate,